Howdy. My name is Jian. I'm an assistant professor in the School of Performance Visualization and Fine Arts. And I'm also assistant director for project development at the Texas A&M Institute of Data Science. So today it's our pleasure to invite Dr. Gorgon Shao from the NIST to give us a talk about digital twins for advanced manufacturing. So Gorgon is a computer scientist in the Systems Integration Division of the Engineering Laboratory at the National Institute of Standards and Technology, NIST. And he has been leading the effort to develop various standards. And he's also I believe, the technical expert for the standard committees, including ISO TC 184, SC4, and several others. And today, the focus will be on one of the latest standards he has been leading on the development. It's called ISO 23247, which is a digital twin framework for manufacturing. And at AM, we just started a semantic lab called Digital Twin Lab. And one of the pilot projects we're working on is about geoengineering applications. And we're also looking potential applications to develop and deploy digital twins for advanced manufacturing, like what exactly is the topic that Gorgon will be talking about today. So with that, I'll just hand over the microphone to you, Gorgon, and let's get started.
Thank you, Jen. Thank you for the invitation, and thank you for the introduction. So like Jen, let me make it full screen first. Yeah, like Jen mentioned, I'm from the National Institute of Standard Technology, as NIST. The topic of today is digital twins for advanced manufacturing. I understand you guys having the digital twin lab. Also, many of you are already digital twin experts. So please let me know if I get too much details, which is for you. Oops, sorry. Yeah, I'm going to introduce quickly about NIST and the program project I'm working on, and then provide the digital twin concept definitions and explain the technical ecosystem. And then I'm going to mention the industry challenges and needs, and then talk about the relevant standards and consortia efforts, and some ideas about future working items for standards. NIST, I don't know how many of you knows or heard about NIST. We are a non-regulatory government agency under Department of Commerce. We have 3,400 employees, 3,500 associates. We have 2 campuses. The headquarters in Gettysburg, Maryland, and there's another one in Boulder, Colorado. 3 major programs. We have 7 labs, 1 MEP program, and a Budget Performance Excellence program. Then the mission of NIST is to promote U.S. innovation and industrial competitiveness by advancing measurement science standards and technology in ways that enhance economic security and improve quality of life. So that's our mission. I'm from the engineering lab. Out of the 7 labs, advanced manufacturing is one of the focus areas. We have programs around additive manufacturing, robotics. The one I'm working in is advanced manufacturing data infrastructure and analytics, called MDIA. I'm managing a project of digital twins for advanced manufacturing to develop a deployed standards measurement science that enable manufacturers to better define, measure, analyze, and control their manufacturing systems using digital twins. So what is a digital twin? Most of people think the concept is started in 2002 by Graves and Vickers. Actually, the twinning idea we can trace back to 1960s. At that time, NASA used the physical twin on the ground level to to match the systems in the space. So to perform what-if analysis and making decisions. Then the word of digital twin first mentioned in 1998 by an actor, using his voice as a digital version of him. Grave and Vickers define digital twin as a digital informational construct of physical system as an entity of its own, then linked with that physical system through entire life cycle of the system. So you can see the fundamental component of digital twin is one physical, one in virtual, then there's connection between these two. There's so many definitions out there. That's why people are confused about digital twins. Here I only list a few of them. The one on the top is a definition from DTC, Digital Twin Consortium. It says a virtual representation of real-world entities and processes synchronized at a specified frequency and fidelity. So this can be applied to all domains. Another one's working in progress under ISO IEC JTC1 and C41, working group 6. Digital representation of a target entity with data connections that enable convergence between the physical and digital states at the appropriate rate of synchronization. Like I said, this is a work in progress. It might change depending on the reviewer's feedback. And the third one and fourth one is mainly for the manufacturing domain. The third one's from ISO, which was published, a new standard Jen mentioned, ISO 23247. The definition in that standard says fit for purpose, digital representation of observable manufacturing element, OME, with synchronization between the OME and its digital representation. OME could be personnel, equipment, materials, processes, products, facilities, environment. The last one is I defined in 2018 in one of my papers, an integrated model that represent, connect, synchronize a part of the whole physical manufacturing systems or process enabled by historical data or real-time data from the physical system or process. So these two are for manufacturing domain. This is a figure I take from a working in progress report under ONGIIC. I think this is a good way to show the whole technical systems within one page. So digital twin is it can digitally represent the real world entity. It's a paradigm, had methodologies, and include all these models, had these abilities, features, and represent different kind of aspect, and involve information technologies and operational technologies, provide business value, require interoperability, security, and covers product lifecycle. The technology involved with digital twins include the sensors, IoTs, communication, data management, all these modeling techniques also. Then digital twin can provide technical capabilities such as simulations, monitoring, optimization, anomaly detection, to name a few. And applications could be product design and energy management, scheduling management, and so on. So digital twins is not, even though my topic is in manufacturing, the digital twin really covers all the vertical domains. For example, the transportation, healthcare, smart city, infrastructure. So I use this figure to represent digital twins in manufacturing. This is physical space. You have product systems, processes, and the virtual space. You mainly is digital twins, which include the model simulation and optimizations. And any factory floor, you have existing application systems with historical data, and plus this real-time data through sensors. So digital twin make analytics and provide parameters for controls through actuators can send to the system directly if you want. So really, digital twin can represent, diagnose, predict, and prescribe system behavior, and to monitor, analyze, optimize, and control the state of the physical assets. So the scope of the digital twins, there's nothing there's no one size fits all, right? So each digital twin application should have its own focus and it's context dependent. Sometimes people complain about we don't have enough data, but oftentimes you have too much data. You don't know which data you should use for your model, for your digital twinning. Really, you only need the relevant data and models for your specific purpose. Application-wise, the digital could be real-time. I mean, most people focus on the real-time aspect. Actually, for some situation, you can have offlines, but you need to update periodically. Like I mentioned, it could be a partial of something. So you don't always need to have a complete virtual duplication, really depending on what you care. And each digital twin may have its own method and tools for that particular purpose. Some people think digital twin must have 3D animation and fancy interface, but actually really depend on the stakeholders' requirements. Sometimes maybe 2D visualization is enough, and sometimes if your digital twin serve as an intermediate component, you may not even need a visualization component. So currently, people are talking about digital twins right now because it's become a really hot topic. But the situation is many big companies, those had enough budget and invest for these technologies, they start to implement digital twins, here and there partially. But many smaller and medium-sized enterprises, they are still struggling to understand the concept and to pay for the change. And also, importantly, they need expertise, they need resources to model their digital twins. And oftentimes they don't even know where to start, how to do it. The challenge and needs for creating digital twins, I mentioned that lack of consensus of the concept or understanding. So that's where the standards and guidelines can provide help. And also there's not enough expertise resources to do this. So the management need to hire educated people to do the job. But the reality is in many shop floor, the information is, they still use paper and pencil, and they use email, they use phone calls to communicate. So that means their information is not digitized, and information sharing and system integration is a big problem. So they need affordable enabling technologies, standards and procedures to use for that purpose. Now I'm going to introduce things we talk about. Standards really help. Will really help this. So I will talk about this relevant standard and consortium effort we participated in. The first one is the ISO GC 184 SC4 WG15. We recently published the ISO 23247 Digital Twin Framework for Manufacturing. And the second one is the ISO IEC JTC1 SC4 effort. They have the working group focus on the concept, terminologies, and use case templates. The third one is ASME VV50. It's verification, validation, uncertainty, quantification, interactions with model lifecycle. We are developing our guidelines. Right now it's in the committee draft stage. The other two is the consortia under OMG, Object Management Group. The first one is Industrial IoT Consortium. Digital Twin Interoperability Task Group. So we're producing a technical report. The other one is joint working group between the IAC, DTITG, and the DTC. Again, produce a technical report. I'm going to talk about each in a little bit more details. ISO 23247, like I mentioned, it's published last October. It's the first digital twin framework standard. It provided framework and guidelines for manufacturers to implement their own digital twins. It specified the fundamental building blocks for digital twins and help manufacturers to select relevant standards for different functional areas, including data collection, data exchange, modeling, simulation, and control. This new standard has 4 parts. Part one is overview and general principles. 2 is reference architecture. 3 is digital representation. 4 is information exchange. I just want to quickly show this diagram, which is digital twin framework. OME we mentioned earlier. That's the physical part. So the one above is the digital twin framework. That includes the data collection, the device control, and this part is mainly the digital twin modeling. And user interface is an important layer on top of the digital twin model. I just take one example for like say machine health digital twin by following the framework developed in the standard. For example, here the OME will become a CNC machine tool. Then the data collection method, we can use MT-Connect standard or sensor data. Then this data is going to be processed and sending into whatever model method you use and tools you're using, and to generate the knowledge and recommendation to user. Of course, those parameters can send back directly to the CNC machine. The second standard working group is under ISO IEC JTC1, SC41. I was the original advisory group member, so we have some ideas and work items. Then we found a home for that, which is the IC41 working group 6. So there's two work effort going on right now. One is establish terminologies for digital twin and describe the concept. That include the terms, definitions, concept. Then the next one is a technical report and provide a collection of representative use cases for digital twin applications for different domains. And there, the members and also proposing new work items on different topics. I've been with this ASME VV50 for a couple of years. I'm a co-chair for this working group. The idea is look at this model life cycle. So VV-UQ interaction. The idea is starting from the requirement of the model until the end of life of the model. We want to make sure the model stay valid and it can generate a trustworthy result. Even though this work is not specifically for digital twin, but the computation model could be a core part of digital twins. So we can see for now, there's not so many digital twin specific standards already finished. A few of the standards are in progress. However, because of the interdisciplinary nature of the digital twin, you have existing standard we can choose from for that particular functionality. For example, if you talking about data collection, you can use existing data collection or sensing standards for that particular purpose. And it's true for the other aspect, or at least a few examples of this existing standard, but those are mainly in the manufacturing domain. So now I'm talking about the consortium effort. The first one is OMG-IIC, Digital Twin Interoperability Task Group. I'm a co-chair of this task group. So members of that task group are from those big companies, but of course they're not there all the time in meetings. So IIC does not develop standard directly, but they may help identify the standard requirements that later can be developed by other standard development organizations such as ISO, IEC, or OMG. In this group right now, we're creating a document, a technical report. Talk about it next. Yeah. So the technical report is called the Digital Twin Core. The idea is, those original equipment manufacturers, they have a very deep knowledge about their equipment, their product that they develop, they build, and they sell. So they are the ideal contributors to provide digital twins of their own product. However, it's very costly for them to develop, to customize the digital twin for each of their customers. So the idea is if they could have a plug and play, like a USB drive, you can use the USB drive, plug in any computer, then you can use that USB. So if they can plug their digital twin of the equipment into the environment that product is going to be used, so that will be ideal. So that report is kind of describe the ideas. In this figure, you can see this is the real world factory, and there's a virtual digital twin, and like say if engine in there, this twin is from the vendor of the real engine, and then you can just plug into this bigger twin. So another one is Digital Twin Consortium. They're similar to that IIC. So it's a consortium with all these big players and each contributing ideas and requirements. So we have a technical report, and provide input to future standard. In this joint working group effort, we have a system of systems, meta model for interoperability. So there's other consortia out there relevant to digital twin. For example, MXD, it's the US leading digital manufacturing innovation center, National Center for Cybersecurity Manufacturing. So it's in partnership with DoD. They provide US manufacturers with solutions and tools. I believe they also give out some grant fundings for companies or universities to develop some tools or find a solution for some real industry problems. SIM Data is a leading independent global strategy management consulting research organization. They're focused on PLM. They have ebooks, report, and Metaverse conferences. Change to Twin is a European project consortium. They are supporting the smaller and medium-sized enterprise in Europe. So they have participating companies, big and small, and universities, research centers. IDTA is a German leading association, similar to the DTC, but their main focus is asset administration sale. So this is going to be a new standard. So looking ahead, I'm going to talk about a few ideas about future standard digital twin development supported by digital thread, integration with multiple digital twins, building digital twins from reusable component, credibility assessment of digital twins and the metaverse. Also some specific sectors. For the digital twin and digital thread, according to Accenture research, most of companies currently using digital twins, they're missing out the values up to 35 to 65% of digital twin investment. That's because of most of the time they're doing standalone digital twins for single functions. For example, they may have a standalone digital twin for product or operations or engineering. They care more about the front end experience. There's no comprehensive strategies for the data integration and sharing. So because of that, sometimes they have to have duplicated infrastructures and the data has to be isolated and it's not timely. And they're missing the enterprise optimization. They only focus on the local functional optimization. And also because of that, it's hard to get the customer data into this to have a bigger picture. Digital thread can provide those digital twins and standards, representations for different lifecycle stages, and can help avoid the data and solution overlap. So if we have guidelines and methodologies that can provide support for this, that will make digital twin development more efficient. So this is a new part we're discussing in the working group 15. Next one is digital twin can be used in all different levels for different product systems. For example, the equipment level, work cell, production line, factory, or even supply chain. However, these digital twins will need to work together. And for example, if a part as a product and also the machine that produce that part, they should interact dynamically and seamlessly. So a potential new standard on this topic will provide the guidelines on how to enable the multiple digital twins to communicate and interoperate. So building digital twins from reusable component, because of currently almost all the digital twins are implemented from scratch, that make it really time consuming and costly. So customized design also make it really hard to modify, extend, integrate, and reuse. For example, the manufacturing knowledge, the attribute of the information models, or even use case configuration. Each time you have to redo those, so that will make it really time consuming. Reuse some of the component. If you have a digital twin library, will help reduce the time effort. In the library, you can have a template for data collection. You can have a common information attribute and modular models, even examples of using technologies and standards. So a new standard could provide guidelines, methodologies to build up those libraries and create template and showing you how to use those reusable components. Similar to the ASME work, I've heard this is just like a credibility assessment for digital twins. So other than the models, digital twins also involve a lot of data collected from the real world and the mathematical models used. And the synchronization and data updating, and even the decision recommendation and control. So all these will have measurable uncertainties. So how to manage this, how to measure, how to perform the testing to ensure the digital twin developed is trustworthy. Metaverse, I know you guys are expert on the AR. So visualization that used to be used a lot in gaming and payment industry. So now I see a lot of interest for manufacturing and also the relevant standards. So in the manufacturing environment, Metaverse can be used in different kind of scenario. For example, you can remember I showed the framework of the ISO 23247. The user entity is on the top, so you can make Metaverse as a one component in the user entity to provide user immersive experience. If that's the case, you need to synchronize your Metaverse with your digital twin in order to have your real-time aspect of your reality. Two, you can have a separate, if you have a digital twin already, and you can have a separate Metaverse to represent the same thing. Of course, you may have some communication in between, but if the purpose is just showing how it looks like, how that can be filled, you may not need to have a strict synchronization between the Metaverse and digital twin. Another scenario I can think of is like you may have a Metaverse for the whole manufacturing environment, but within the bigger environment, you may have multiple OMEs and their digital twins. So you want to show how things interact and connected. So once in a while, you probably need to calibrate it and update it. So if you have a new part of the standard to introduce the concept, definition, the possible scenarios, and provide guidelines, methodology for these integrations. Also, for ISO 247, right now it's for the generic manufacturing domain, but they can be extended or specialized for some specific manufacturing domains, such as biomanufacturing, semiconductor manufacturing, or additive manufacturing. Because of they may have some special element or requirement, so you can update or modify the existing part to satisfy the new requirement. Okay, so to summarize, digital twinning is the key part of nowadays digital transformation for advanced manufacturing. The key word of the definition is fit for purpose. That means you don't always have a complete duplication of the reality. Really depending on the context viewpoint. There's still a lot of confusions, a lot of help needed out there, especially among those smaller and medium-sized enterprises. Standard definitely can help manufacturers to understand the concept, to use common terminologies and follow best practice and speed up the implementation. So the key standards require the concept, definition, vocabulary, terminologies, framework, guidelines, and implementation use cases, examples. Consortia effort confirm industry needs and requirement and can help identify potential standard requirements. So there's some ideas or potential topics for 23247 or even other standards. That's it. Thank you for your attention and any questions.
Great, thank you. It's very informative. So any questions from our audience?
So I have a quick question for Gordon. This is David Zhang, and I'm a professor in construction science here on campus. First of all, I really appreciate your presentation and great overview of NIST's perspectives on digital twins for additive manufacturing. Since my background is in construction, basically the built environment, I'm just wondering whether NIST has a group of people who are looking at this advancing the digital twin technologies for the built environment, like the construction projects, buildings, roadways, tunnels, or those sort of the infrastructure facilities and the buildings for the smart cities.
Right. So, like I said, even though my interest is focused on manufacturing domain, but even within the standard committees, some really have a broad interest. That definitely covers smart city construction, region buildings. NIST, we do have people working on the constructions and buildings, but I don't think they have a specific digital twin project for that. A lot of people, of course, they're doing data-driven models, they're collecting data, data analytics. They may use the keyword here and there, but I don't think they have done, contributing a whole lot of effort, particularly on the.
But yeah, it's great to know. I recently started a project with ExxonMobil, Chevron, Dow here in Houston, and we are looking at this digital data interoperability issues, and we are realizing that ultimately, probably in the next decade or so, even the construction industry needs to embrace this concept of the digital twins to do a lot of things, as you mentioned in your presentation. It's not just about solving one problem, but it's about improving the productivity in general, profitability, and also safety of the construction workers on job site. I think I have been doing research in this area, but this is the one of the major visionary areas that we work on. So I'd like to reach out to you, Gordon, and also Jian Tao as well. So to create potential possibilities and collaboration opportunities in the future.
It's great,
Sure.
definitely. Yeah.
Thank you.
Andrew, do you
Yes.
want to go ahead? Yes.
Thank you, Gordon, for a great presentation. Really appreciate it. I actually have a couple of questions. One, is it possible to get that presentation so I can share it with colleagues that weren't able to make it today? The slides.
You know, I can give Jian a PDF version of it, but because of this, there's a lot of working in progress, unpublished work. I don't want it to be out of control, you know, on the website, or you know, that way it may upset some people.
No problem. And
Yeah, I think Andrew is a LAN member, so we'll share internally, and well, should be fine. Yes.
And my real question is, you proposed earlier as part of the working group that at the manufacturing stage, when you showed a little motor, when the motor is manufactured at a company, that OEM provider that creates a motor because they have deep knowledge of that specific asset, that creates a digital twin, which then ultimately becomes part of a larger digital twin. Is that the thinking behind of the direction where we should go? And have we thought about the implications that that's gonna present to the world?
No, you see, this world doesn't limit any creative ideas, right? So that is just a research idea. Like I said, that's a work in the report of IIC. It's a consortium effort. Right. It's not a standard. We just think that would be ideal if we can make a digital twin as a USB drive. That way, sure. The people who are really good at creating or know the physical equipment can create a perfect digital twin, but then to eliminate all the tedious effort for people to integrate things together. And really just when they purchase the hardware, they can have a optional or given a free digital twin come with it, but they're guaranteed to plug into their whatever system. The picture is just showing the idea.
Yeah, no, I mean, I like the idea, but the implications of that is because that motor, well, that's in turn made out of different components which have their own digital twins. I mean, each little switchboard and chip inside of that motor has a digital counterpart, and you keep expanding that, which ultimately would mean, if we go down that road, that every physical thing that exists today would have a direct digital counterpart, i.e. we have chips in every inch of roadway, perhaps in our doors and so on, because these are all individual items, and the implications of that are just very interesting. Yeah. Thank you.
Yeah, so I can only say that's just one of the ideas, and right. If people like it, they can adopt it.
Yeah.
It's great. Thank you, Gordon. Thank you, Andrew. I saw Abhishek has a question posted on chat. Okay, are you able to talk? If you can ask it directly.
Oh, yeah, sure. Thank you, Dr. Shao. First of all, I have two questions, actually. The first one is with regards to the offline digital twin, which you mentioned. I am not able to understand how is it different from any sort of simulations which you have been doing till now.
Yeah, so that's a good question. I answered someone's question even today, because he's reviewing some materials, but then the other party claim is a digital twin, but to me, it's really just like a digital model. So the key difference between digital twin and a simulation model is the synchronization between, like when I talk about the concept, I said the three parts, right? One is physical, virtual, in between. So if we have been doing digital modeling for a couple of decades, and this is nothing new. But the digital twin bring in the connection, synchronization between the virtual and physical. So that's the key thing to differentiate a digital twin and a simulation model. However, because of right now, people using the digital twin word really freely, right? They call everything a CAD model a digital twin. So when I say offline, it means you have the channel connected, but you may not update your data every second. So you may just update it once a week or once a month. That is fine, as long as you have an update, a connection to refresh your virtual twin. So that means after the refreshment, you are representing the physical twin, which is fine at that moment. But during the offline period, it's not guaranteed. Okay, but the mechanism allow you to do that.
Okay, thank you, Dr. Shao. And the second question is again related to the synchronization. So what are the current ways in which the NIST or like even the industry has been tackling the issue of data synchronization, especially when it is coming from all sorts of different sources?
Sorry, I missed some part of your question.
Yes, so I was asking, what are the current ways in which NIST and industry in general have been trying to tackle the issue of data synchronization, especially when there are like multiple sources of data available?
Right. Yeah. Currently, the industry, most of them are using digital models, right? So when you create models, of course you need data, and those data may be collected historically or in real time. I mean, that real time is really no strict definition of what is a real time. We may say near real time because of all these challenges. So maybe 5G, 6G may help you better realize the real time. So even some industries claim that they have real time data may not be actual real time. So there's still a lot of issues.
I see. Yes. From experience, I know that it is kind of complicated to even like generalize this framework, like when we are trying to synchronize. So are there like any standards which NIST has already worked with, or you might have known about, wherein we can generalize the issue of synchronization?
Like I said, there's only a few digital twin specific standards out there right now, but you can do some research on the existing ones. Like for example, for the data collection or data transmission in the manufacturing domain, we have MT Connect. That's something you can collect the real-time status of equipment or machine while it's running. So to log, the data such as start, stop, and other status. So when you have these real-time data, of course you don't have to use all of them. You can just selectively to have to get the data you're interested in, and then you process those data. And to model those data. So that means you can find some standard for that purpose, for that synchronization, for data collection and synchronization purpose.
Okay. Thank you, Dr. Shao.
Okay, great. We also have Eduardo. I notice you have some questions. Do you want to unmute yourself and ask questions directly?
Sure, thank you. Thank you for the great presentation. My question is, digital twin standards, it seems like it shares lots of similarities with already in place standards in automation regarding data protocols, sensors, controls, and etc. So can you elaborate a little bit more on what's the differences that you're thinking about as far as the those standards?
Yeah, I mean, like the one I mentioned the most in this presentation is ISO 23247. So that is a digital twin framework standard. And the idea is provide guidelines and the understanding of what is a digital twin, what the major component a digital twin should have. So, and follow what kind of thinking you can organize your digital twin project. So for a factory manufacturer would like to implement a digital twin, they have no idea. First, they don't know what is a digital twin. Two, even they have the money, they don't know how to start, where to start. So with this framework standard, they can clearly understand, okay, I want to model my OME, which is maybe a CNC machine. And in order to do that, I need to come up with what kind of parameters I really care about. And for that, how can I collect that data? And what kind of method and tools I need to use to model that digital twin. So really the framework standard provide guidelines for people to understand what is a digital twin and how to start to work on digital twin. And the traditional automation standard, a couple of years ago, I also worked on the process control standard. They're not like talking about the idea of a digital twin as a whole. It's really care about whether it's optimization protocols and how to send out the control command and that kind of thing. So they are different.
Very good. Thank you so much.
Great. We have one more question from Akash. Do you want to unmute yourself and ask questions directly?
Thank you, Dr. Tao. Hello, Dr. Shao. I'm Akash. I'm a fourth-year PhD student in the Industrial Engineering Department, and my question is from a cybersecurity perspective. And I wanted to know how useful these digital twins are for cybersecurity research. Because when you're doing cybersecurity research, you don't want to take down your actual machines and test defenses to see how effective they are against existing cyber attacks. And when we look at these digital twins, they are limited to in the sense of what they want to be simulating or emulating, for a lack of better word. And cyber attackers, they may have access to some of the deepest layers of these machines, which includes the control loops, which may not be modeled in digital twins. So again, my question is, how useful is the current state of art digital twin for manufacturing cybersecurity research?
Yeah, I mean, this is a really good question. The cybersecurity is very important topic, and you have to face it. Like I said, the digital twin still in its infancy stage, even though it's been a few years. Even in the standard, we kind of mentioned that, but just that's it. We just mentioned that cybersecurity is important for when you transmit data and having all these different functional areas. But someone has to contribute their research ideas and effort about the cybersecurity, working together with digital twin to make it more practical, more useful. Yeah,
No,
so I even suggest you do, do some research on this. Not so many people have contributed too much yet.
Sure. I saw that one of the consortia members was MXD that do manufacturing cybersecurity.
Yeah.
That looks like that was about just one I found, but sure. Thank you for your take on it.